which is related to the slope of the tangent line. So related to the slope, of the tangent line. And the difference is the following. So when we talked on Wednesday, we talked about the slope of the tangent line. And this was at a specific point. It was like, find the slope when x equals 2, x equals 3, x equals 0, whatever it might be. And the formula we had was limit as x goes to c of f of x minus f of c all over x minus c. When we use the word derivative, we are talking about the slope of the tangent line, except it is at any point. This was slope of the tangent line at a specific point. This was at any point. And we'll learn the formula for this, but it is often represented as f prime of x. Whereas this one is represented as m tan, slope of the tangent line at x equals c, right? This line is at x equals a point. This goes with this, and this is the general equation for the slope at any point. Where is the comma, Graham? Oh, like an apostrophe? That's what you meant. Yeah, it is.
Is at the top.
Yeah, comma at the top. There you go. All right. Yesenia's not here today? Okay. Okay, so I want to spend a few minutes talking about how to find the equation of the derivative, or the formula for it. So the derivative formula is based on basically what I did last Wednesday when we talked about slope of the tangent line. So I'll do something similar today. So imagine we have some parabola here. We have some point here called P, and we want to find this. Now, here's what we know about this function. We know that this right here has an equation of y equals f of x. We don't know what it is. It's like some kind of parabola, probably. We don't know what it is. We also know that P has some x-coordinate here. And then this, so like maybe x is 3, maybe it's 5.8, maybe it's 2, who knows what it is. Some x-coordinate. And the y-coordinate is f of x. In other words, we're going to plug in whatever we get for x. Sorry about that. Plug in whatever we get for x into our equation, and we get f of x. So maybe this is 3. We plug in 3. I don't know what we get. Something, right? Like negative 5. Who knows? So point P has the coordinates x. 1, 2, 3, 4, 5, 6, 7, 8.5. Who knows what the number is? Could be anything. That's the whole point. Right? It could be any number, right? Like P could have been here, P could have been here, P could have been here, P could have been here. The goal is we want to find some equation that will tell us the slope of the tangent line everywhere. So here, 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 here. So we don't have to find each one individually. So how do we do this? Well, as you all know, to get slope, you need to have 2 points. So here's another point, Q. So I could find the slope between these two lines. I'll get this brown, blackish line. The problem is, the black line isn't very close to the blue line in terms of slope. The black line is a pretty bad approximation. You can use the word estimate, whatever word you want to use. So we really don't want Q over here. We want Q to be a little bit closer. Before we do that, though, we should probably give Q some coordinates. So the coordinates I'll give Q are, I'm going to call it x plus h, where this distance right here is h. Okay, so h is this distance between the P and the Q. So maybe it's 3 units, maybe it's 8 units, I don't know what it is. I'll call this h here. This is h, which is the distance between P and Q. So Q's x-coordinate is x plus h, and therefore the y-coordinate will be f of x plus h, right? You just take that and plug it into the equation, f of x plus h. All right. But as we just said, we don't want Q to be that far away. Let's bring Q a little closer and see what happens. So maybe Q could be here. This will be better. So now let's draw this line here. So I've got this yellow line now. The yellow line is certainly better than this random green line, but it's nowhere near as good as the blue. But what did we do here? We just moved Q over. So you all might agree that we made this distance smaller. Before the distance went all the way to this green. Now it's up to only the yellow. So the distance, h, got smaller, and the line got better. Let's do another one. Maybe we could put Q like right here. Maybe this is Q. The distance is super small, that's all the distance there is. The line is like really close now. Like brown is really close to light blue. It's like almost the same slope. So what you're noticing is that as Q gets closer to P, in other words, as the distance between P and Q gets smaller, the approximation gets better. So in an ideal world, how much should the distance be between P and Q? In an ideal world, how much should the distance be between P and Q? 0. So we want the limit as that distance, h, goes to 0. And what are we looking for here? We're talking about slope. What's the equation for slope? y1 or y2 minus y1 over x2 minus x3. Now nobody really writes the formula like this. Most people write it a little bit simplified form. So most people will write that the derivative, the definition of a derivative, or the formula for a derivative, is the limit as h goes to 0, f of x plus h minus f of x, all divided by h. Here it is. This we have to know. This is the money formula that we will use over and over again. And this formula, or this definition, will tell us the derivative, or rather will give us an equation for the slope of the tangent line, i.e. it will give us the derivative which we can use to find the slope of the tangent line at any point on the graph. And I'm going to do some examples right now. Jump in. Left and right, yeah. It's like left and right? So this will be like 5 and it's a negative. So depending on which way we're going. Good question. All right, so let's jump in with an example. So let's do problem 3, page 3, level 4, problem 1. Page 3, level 4, problem 1. So page 3, level 4, problem 1. It says find derivative at x equals 2. And they gave me f of x x equals 2. This has to be specific. Why is this specific? Because they told me the specific point. They said, we only want this. We only want the slope of the tangent line, synonym for derivative. We only want the slope of the tangent line at x equals 2, at a specific point. Which means we need to use this equation. Questions on that logic? So with all these limit problems, we need the point P. What is the x-coordinate, Giselle, of point P? 2. Anthony, how am I going to get the y-coordinate now, Anthony? Yep, and what am I going to get? $25. Absolutely right. Plugged in 2 here, got 25. Alright. So, Shunli, which of these are C and which is f of C? Yep. Why is she right, Pops? Yeah, right. I mean, remember, it's y2 minus y1 over x2 minus x, so slope. Good. So let's plug in now. What do I plug in for f of x, Omar? Mm-hmm. Okay. All right. Question so far. Now, Brandon, what can I do upstairs here, Brandon? What can I do upstairs? Okay. Before I do that, Brandon, I think that's a great idea, and I'm about to do that. Can I simplify upstairs real quick before I do anything? Like, how could I rewrite the upstairs so it's a little bit more simplified? Yeah, so what am I going to get? So hold on. Negative 1 minus 25. What do I get, Brandon? Yeah. So now we do Brandon's strategy. Plug in the 2 for x, always with